Hello students, your teacher here, Mr. Sarasinski, with another episode of Algebra 1, Lesson 8.5, Solving Quadratic Equations by Factoring. And we have already spent a day factoring trinomials. And if you remember, we're looking for factors that add up to equal b. And let me go ahead and remember, standard form of a quadratic and standard form of a trinomial. And we're looking for factors whose sum is b and whose product is c. All right, so it says, in many cases, we can find the solutions or roots, zeros, intercepts of a quadratic equation by factoring rather than graphing. Follow the steps below to find the solutions of the given equation by factoring. So sometimes you won't be able, I shouldn't say that. You can always find the roots by graphing. Unless this is faster, you can use this, okay? So you're being given multiple methods to find the same thing. You're being given multiple methods to find the roots, whatever you want to call them, roots, zeros, x-intercepts, solutions, and it is going to be your job to determine which one is the most effective given the question. And obviously in this set of notes, we know that factoring is going to be the easiest. Okay, so says set the quadratic equation equal to 0. So we're going to replace this y with a 0. And then we're going to factor. So we're looking for factors of 10 that add up to equal 3. So there's 10 and 1, 5 and 2. Okay, 5 and 2. So that's x plus 5, x minus 2. And this is the way it has to be, right? Because 5 times negative 2. All right, and 5, like I was saying, 5 times negative 2. Sorry, I got interrupted. Had to pause for a second. 5 times negative 2 is negative 10. All right, so now set each factor equal to 0. I'm going to draw a line. And I'm going to set the binomial on the left equal to 0. And the binomial on the right equal to 0. And these are one-step equations. So how do we solve them? Subtract 5 from both sides. X equals negative 5. Add 2 to both sides. X equals 2. So it says, write your answers using curly braces, otherwise known as set notation. So the solutions to this equation are negative 5 and 2. And this is the way. So let's keep going. Number 1, factors of 3. 3 and 1. X plus 3, x plus 1. It was already set equal to 0. And then we're going to draw our line down the middle. And we're going to set each one equal to 0 separately. Okay. Subtract 3 from both sides, and x equals negative 3. Subtract 1 from both sides, and x equals negative 1. Solutions. X equals negative 1. Whoops. I like to go numerical order, least to greatest. There we go. X equals negative 3 and negative 1. Number 2, already set equal to 0. We need factors of 24. 24 and 1, 12 and 2, 8 and 3, and 6 and 4. And 8 and 3 will add up to equal 11. So we have x plus 8 and x plus 3 equals 0. 8 plus 3 is 11. 8 times 3 is 24. That's why these numbers work, in case you're wondering, okay? So let's draw our lines, set each one equal to 0. Subtract 8 from both sides, and you get x equals negative 8. Subtract 3 from both sides, x equals negative 3. Solution set notation, least to greatest with -8 first. Okay. Number 3, factors of 2. Wow, that's a hard one. Okay. But we need it to equal -2 and +1. So that means the 2 needs to be positive and the 1 needs to be negative. 2 plus -1 is 1. And 2 times -1 is -2. That's why these numbers work. Okay. The signs work too. You got to be careful with those. Okay. Set each one equal to 0. X equals -2. X equals 1. Solution set notation, -2 comes first. Number 4, factors of 27. 27 and 1, 9 and 3. Since we need it to add up to equal 6, we're going to use 9 and 3. And since it's a +6, we're going to do +9 and -3. Okay. Subtract 9 from both sides, and x equals -9. Add 3 to both sides, and x equals 3. And there we are. Number 5, 21. 21 and 1, 7 and 3. Since we need it to add up to equal -10, we're going to do 7 and 3. And since b is negative, we need both of these to be negative. So x minus 7, x minus 3. That's the only way to get them to add up to equal -10. And then if you multiply, they equal a positive. Okay. X minus 7 equals 0. X equals 7. X minus 3 equals 0. X equals 3. X is equal to 3 and 7. Number 6, factors of 20. 20 and 1, 10 and 2, 5 and 4. We need them to add up to equal -1, so we're going to do 5 and 4. And since we need -1, we're going to make the 5 negative and the 4 positive. Draw our lines. X minus 5 equals 0. X plus 4 equals 0. Add 5 to both sides, and x equals 5. Subtract 4 from both sides, and x equals -4. Set notation, x equals -4, comma 5. Okay, number 7, factors of 25. Okay, number 7, we need factors of 25. And 5 and 5 are what works. So we have x plus 5, x plus 5. Set each one equal to 0. Okay. Number 8, factors of 16 that add up to equal -8. Four and 4, so we'll use -4, -4, because a negative times a negative is a positive. Okay, only one solution. So this goes back to when we were graphing to find the solutions to a quadratic. Remember, there can be 2, 1, or 0. I don't think any of these problems are going to be the ones that have 0, but it's just good to remember that it's okay if you only get 1. Okay, moving on, number 9. There is no C. There's no C, Okay, so what we need to do first is take a GCF. So there's no C, so I can't, there's nothing to decide the factors of, okay? But I do notice that there's an X in each one of these terms. And so whatever is in each term, I can take out. And then what do I multiply X by to get X squared? X. What do I multiply X by to get negative 8X? Negative 8. So this one's actually, I mean, and if you know how to do a GCF, this one's actually a little easier, okay? X equals 0 and X minus 8 equals 0. Add 8 to both sides and you get X equals 8. So anytime you factor out a variable as a GCF, it will always, 0 will be A, not the, because we have 2. So in this case, we factored out X as a GCF. And when you factor it out, you just set it equal to 0. That's all you do. Even if you factored out 3x, well, 3x equals 0, divide by 3, and x is still going to equal 0. So no matter what you factor out, if you factor out a variable, one of your factors is going to be 0. So x equals 0 and 8. 10. 3, so we still have a GCF. So these are GCF examples. And so this time I see that there's a factor of 3 in each of these coefficients, so I can take that out. And there's an x in each of these terms, so I can take that out. What do you multiply 3x by to get 3x squared? X. What do you multiply 3x by to get 15x? 5 equals 0. And then set each one equal to 0 and solve. 3x equals 0, x plus 5 equals 0. Well, if you divide by 3 on both sides, this is just going to be 0, just like I said before. If you factor out a variable, 0 is going to be one of your factors. And then subtract 5 from both sides, and x equals negative 5. Your factors are negative 5 and 0. All right, number 11, GCF. We have a 6 in both, and we have an x in both. And so what do you multiply 6x by to get 6x squared? X. What do you multiply 6x by to get negative 12x? Negative 2. Set each one equal to 0. X equals 0 and x equals 2. Okay, number 12. Okay, each of these has 2 as a factor, and each one has an x. What do you multiply 2x by to get 4x squared? Well, that would be 4x. What do you multiply 2x by to get negative 6x? Negative 3. Set each one equal to 0. Divide by 2 and x equals 0. Add 3. Divide by 4. So our two solutions, our two roots, our two x-intercepts are 0 and 3/4. All right, the next 4 examples are called difference of squares. And so in difference of squares, in your binomials, you're going to have opposite signs. Why do we have opposite signs? Because when you have opposite signs, the inside terms will cancel out when you're factoring. And you'll see what I'm talking about here in a second. All right, so x squared minus 64. Well, what's the square root? The square root is x, and the square root of 64 is 8. So x plus 8, x minus 8 equals 0. And then we set each one equal to 0. X equals negative 8, x equals 8. Okay. And if we were, what I want you to see is in this difference of squares, and I'm going to pull it off to the side here for a second. So if we were to multiply this out, x times x is x squared, x times negative 8 is negative 8x, 8 times x is positive 8x, and 8 times negative 8 is negative 64. These two inside terms, because they're the same but have opposite signs, are going to cancel out. And then all we're left with is x squared minus 64. So this is why they call it a difference of squares, because the inside term are going to have different signs and they're going to cancel out. And you can take the square root. Square root of x squared is x. Oops, let me go back to my other color. Is x. The square root of 25 is 5. So x plus 5, x minus 5 equals 0. Set each one equal to 0. And I realize I skipped this step in the last one. Sorry about that. But x equals negative 5 and x equals 5. Number 15, the square root of 4x squared. And okay, so one thing that I want to tell you is that recognizing, right? How do you recognize when it's a difference of squares? Well, if you look and it's only two terms, okay, there's no b term, and then everything in the binomial is square rootable. Like I know that the square root of 4 is 2. I know the square root of x squared is x. I know the square root of 81 is 9. Everything that's in this equation is a perfect square. Okay, you can take the square root of it. And so that's how you identify them. If you see a bunch of perfect squares, then they're setting you up to take the difference of squares. Okay, square root of 4x squared is 2x. Square root of 81 is 9. So 2x plus 9. 2x minus 9. Set each one equal to 0. Subtract 9, divide by 2. X equals negative 4.5. Subtract 9, or add 9, divide by 2. X equals 4.5. So x equals negative 4.5 and positive 4.5. Number 16, the square root of 9x squared is 3x. Square root of 49 is 7. So 3x plus 7. 3x minus 7. Set each one equal to 0. Subtract 7, divide by 3. X equals negative 7/3. So add 7, divide by 3. X equals positive 7/3. Number 17. Each of these are not in standard form, so all we need to do is one step to get them in standard form. And sometimes that takes some rearranging, like in number 20. Well, all of these are pretty much one step. Okay. All right, so we need to subtract 21 from both sides and move that 21 to the other side. Now we need factors of 21 that add up to equal 4, 7, and 3. And since we need 21 to be negative and 4 to be positive, I'm going to do x plus 7, x minus 3. Set each one equal to 0. And subtract 7 on this side, x equals negative 7. Add 3, x equals 3. So x equals, oh man, Okay, x equals -7, comma 3. All right, number 18. Subtract 4x from both sides. Okay, and to have it in standard form, we're going to put it in the middle. So x squared minus 4x minus 45 equals 0. Now we need factors of 45 that add up to equal 4. So we have 45 and 1, 15 and 3, 9 and 5. So that would be, since we need the middle term to be negative, I'm going to make the larger factor the negative. So x minus 9, x plus 5 equals 0, right? Because they had to multiply to equal a negative 45, but then add to equal a negative 4. Set each one equal to 0. And x equals 9, and x equals -5. Number 19. Subtract 7x from both sides, so we can set it equal to 0, and you get x squared minus 12x minus 64 equals 0. And factors of 64, 64 and 1, 32 and 2, 16 and 4. And it looks like 16 and 4 is going to be the one we use. And since it's negative 12, we're going to make the 16, the larger number, negative. So x minus 12, x minus 16, x plus 4 equals 0. Because negative 16 times 4 equals negative 64, and negative 16 plus 4 is negative 12. Set each one equal to 0. And you get x minus 16 equals 0. So this will be x equals 16. X plus 4 equals 0. This will be x equals -4. So x equals -4 and 16. Number 20. Subtract 4x and 1. We can do it all in one fell swoop. Okay, so we get x squared minus 14x plus 48 equals 0. Factors of 48 are 48 and 1, 24 and 2, 12 and 4, 8 and 6. Okay. And so we're going to use 8 and 6 because they add up to equal 14. And since it's -14 and positive 48, both factors are going to be negative. Set them equal to 0 and solve. X equals 6 and 8. Number 21. Oh, look, they switch sides on us. Okay, no problem. Subtract 11x squared from both sides. You get 0 equals -10x squared plus 8x. And this is a GCF. I can tell that I can take a 2 and an x out. And I'm going to take out -2 and x. What do you multiply by -2x to get -10x squared? 5x. What do you multiply by -2x to get positive 8x? That would be -4. Set each one equal to 0. -2x equals 0. Solve for x, and you get x equals 0. 5x minus 4 equals 0. Add 4. So you get 5x equals 4. Divide by 5, and x equals 4/5. Number 22, subtract 9 from both sides. And you get 16x squared minus 9 equals 0. This is a difference of squares, similar to numbers 13 through 16. So everything in this quadratic is, you can take the square root. Square root of 16 x squared is 4x. The square root of 9 is 3. So 4x plus 3, 4x minus 3 equals 0. Set each one equal to 0 and solve. Subtract 3 and divide by 4, x equals negative 3/4. Add 3 and divide by 4, x equals positive 3/4. And that is all. Factoring, solving quadratics to find the x-intercepts. I'm your teacher. This is the way. Until next time.